Ethereum devs. What I'm going to be talking to you today is about a way to add Ethereum power to your August or Yale front door lock via ERC 721 tokens. You might have heard of this particular type of NFTs, first through CryptoKitties, the Beeple auction maybe, and lately Bored Apes, Zedrun, Axes, and many others. Now, today we're actually going to be using NFTs as a utility token. So there's going to be some function attached to the token which is operating our Yale lock. So the cool thing about using NFTs for access control is you can define all of the rules. You can define exactly how the token is going to be used and who can use the token. For example, you can set up a rule so that only you can transfer the tokens. So when you transfer them to another user, they can only hold the token. You can set time locks. You can burn the tokens at any time, or you could even set up an auction so that the winner of the auction will automatically receive the token, and then for a limited amount of time they can have access to your apartment or whatever you're using for access. So today we're actually going to be using the TokenScript framework to give us a nice quick user interface for the lock, and I'm going to talk you through how to set up each component, like the interface to the Yale lock itself. We're going to set up we're going to mint some door tokens. We're going to write the token script, and then we're going to put them all together and see how it works. And then finally, I'll take you behind the scenes to show you exactly what's happening. Okay, first let's have a quick look at the lock. So here's the standard Yale lock with an app that connects to it. And I'm just going to open the front door for you. There we go. You open and close it up. So this is the default way that we operate the Yale lock. Okay, let's get started. So the first thing I want you to do is to clone the TokenScript door client. So first of all, go to the Alpha Wallet GitHub repo, just github.com/Alpha Wallet. Open up the TokenScript door client, which you'll see there. It's a public repo. There's a few instructions there which you can go into if you wish. What we're going to do now is just clone this repo. So just grab a link, open up your console, git clone the repo. It should come down. Now, this is actually a Xamarin Framework app. So you're going to be using Visual Studio. So we've got that installed here. So pop that guy open. So you'll need Visual Studio with the Xamarin Framework. So cloning that straight from the repo, open it up, and you'll see if you open up main activity, you will see there's a bunch of keys that you have to find here. So the instructions to find those keys are in the GitHub repo instructions. You'll need to already have a working Yale lock installed and probably a rooted phone. So after setting up your keys, what I want you to do is install this onto a test phone that you have. So in my case, I have a spare Google Pixel 1, which I like to use, and set that up. Click install. It'll go through the build, and it is going to deploy. So here we go. It's just deployed. And you can see it's connecting to the bridge. Okay, so we are going to deploy this app now. So this is from the Xamarin project. It's opening up, and it's going to now be scanning for the lock to try to find the lock. It's looking through the Bluetooth devices. There you go, it's found it. Let's do a quick test to make sure this works. And just running through its tests. There we go. Okay, so you can see that this is communicating with the August lock. Okay, now we've established that, the thing we want is the device address. So this address here is created when the app first runs. It stores it, and it's a persistent address that's used each time. Now, this address doesn't actually do anything other than doing ECDSA cryptography. So there's no tokens on this address. So what I'm going to do is just click that link, and I should get a, yeah, there we go, copied address to clipboard. So that's what I want. So I'm going to go swap over to Telegram and pop that link, pop that link into Telegram. There we go. The next thing we're going to do is mint our NFT. So if you go back to the TokenScript door client repo, you can see there's this Solidity entry token file here. Just click on that guy, click on the Solidity file. This is a super easy way to do it. Click raw. Then here's the Solidity contract that I've got. It's a standard ERC 721 from OpenZeppelin, but I have made one small modification, which is I have added this mint using sequential token ID just to make it super easy to mint new tokens. So let's go to let's open Remix. So Remix is how we're going to deploy the token. So here's the standard thing. It's just remix.ethereum.org. You will need the MetaMask plugin, which I already have. So I'll open that up and connect my test account, which I just created here. So I have this test account. So the next thing I need to do is just get some Arinkb. So I shall just go to the Chainlink faucet, copy my address in, ask for 0.1. I'm not a robot. So we are back again, and let's go to Remix, and yep, you can see that we've received our 0.1 ETH from the faucet. So let's use this thing. What I'm going to do is create a new file, call it, create a new file, call it doortoken.sol. And you can see we've got a blank file here. So let's go back to our contract, just copy paste that guy in. There he goes. Now you can call it something else, whatever you like. I've set up a little surprise for you guys. So I've actually copied the Bored Apes metadata. So when you open this token in your wallet, it appears that you've got Bored Apes, but you haven't really. Okay, so open up the deploy and run transactions window. Click on injected Web3, and you should see your account. And you see, yes, okay, 0.1 ethers. So that should be enough to do everything we need to do today. Make sure that you're selected the right class to burn. So that's doortoken.sol. And finally deploy. So MetaMask should pop up, and then we'll ask to confirm a transaction. And now we just wait for the transaction to finalize. It shouldn't take long. Arinkb is usually pretty quick. And just there we go. So this is our contract here. And oh, there's the transaction hash. So here's the contract functions. Now what I'm going to get you to do is to mint some door tokens. So we're just going to call this utility function that I added, this custom utility function. So just click mint using sequential, and we should get the MetaMask pop-up. Confirm that you're happy to mint then. Let's mint one more, just for fun. Okay, so now I should have 2 of these tokens in my wallet. What we're going to do now is transfer this wallet to Alpha Wallet, so that we can use a token script. So to do that, you have to open the wallet. See, we've lost a little bit of ETH, burning the transaction. Yeah, the mint function is still pending. What we're going to do now is just take out the private key. So the method I'm going to show you, don't use this for a real account. It's only good for test account. So we go account details, export private key. You are going to have to type in your account password, open it up, and there's my private key. There's nothing on this key apart from that 0.01 Rinkeby. So just copy that into the clipboard, and I'm going to show you a very insecure way of transferring it. Again, don't do this with the real key. So I go to saved messages in Telegram, paste the private key in there, send it off, and now that's available on my device. The next thing to do is to set up the token script. So to do that, we're going to go back to the token script door client repo, open up the token script folder. You'll do this on your local computer, and you'll find this lockentry.xml file. Now I want you to open that up in Visual Studio. So it should look something like this. So this is a token script file, and it comprises of XML. It's an XML wrapper around some XML definitions. We have CSS here, you can see, and we have some HTML and JavaScript. And all these are ways of programming a user interface onto tokens. So we only actually need to edit 2 things in this file to get it working for you. We just, the first thing is our contract address. So what I want you to do is to go to Remix, which hopefully you still got open. You can see under deployed contracts, you can see the function, the contract that we just deployed. You can check the name here. Let's see, door tokens, yeah. So let's copy the contract address here. Go back to Visual Studio Code and paste that guy in. That's the first step. So the next thing I want you to do is search for IoT in this folder. You will see in the JavaScript snippet, you'll see IoT address. This is the address of the remote client that we found in a previous step. So if you go to your Telegram, we recorded it there if you remember. So here it is. Let's just pull that out and paste it in. And that's it, you're done with the token script. And now you're going to take that contract address that I just put here, go back to the Xamarin app and find the function check token balance and unlock, and you are going to put your new token address in there. Save that and redeploy the app. Now what you're going to do is find the token script that you just edited in your directory folder, and you can just drop that straight into your Telegram. There we go, send that guy. And now what you're going to do is open that in Alpha Wallet. Okay, so the next step is to import the private key that we exported from MetaMask into Alpha Wallet. So if you haven't already installed Alpha Wallet from the Play Store, then please do that now. Let's grab this private key, and I'm going to switch to Alpha Wallet. Settings, change. I'm going to import the wallet. It's a raw private key, so you need private key. And I am going to import that guy. So I've just imported it. Let's switch over to the wallet, and you can see we've already got the door tokens imported. Let's just give it a few seconds, and it should spot our Rinkeby. Yeah, there it goes. Okay, so it's seen our Rinkeby, it's seen our door tokens. So before we install the token script, let's just have a quick look at the door tokens. And oh, Bored Apes, great. Okay, so that's okay. Now we're going to upload the token script into Alpha Wallet. So the token script that you previously copied to Telegram, let's go into there. You can see that the first intent is Alpha Wallet. So let's go into Alpha Wallet. It opens up, and you can see straight away that the issuer of the token is now token script debug. So that tells us that we've been successful. Let's click on here. You can see it's uncertified. After you've finished debugging your token script, you can sign it, and then after it's been signed and uploaded to the repo server, this will then become a nice green tick, just like a website certificate. Okay, so we're going to click on one of the tokens that we've got. You see a little history there. Let's the token script contained two verbs. We've got a mint verb to mint new tokens, and we've got an enter verb. So let's click on enter, and you can see that we've just received the challenge from the door client. So let's click enter. So I'm now being asked to do a signed personal message on this challenge. So I'm going to go ahead with that. I'm just going to use my fingerprint. Okay, let's go. So the sign's successful, and there you go. And it's just transmitted to the app. So let's try again. So let's go click enter. So this should actually, the verb should actually be toggle, technically, since and we're in, and it's just locked. So finally, here's what's happening behind the scenes. So the first thing we have, when this token script door client first opens, it creates its own private key. Once it's got that private key, as you saw, what it does then, so on opening, it will then try and connect itself to the token script bridge. So what happens, as it logs into the token script bridge, that will then send back some challenge bytes. What happens now, the client will sign those challenge bytes, return the signature back to the proxy bridge. What happens then, the proxy bridge EC recovers the token script door client address and then creates a mapping of the token script door client as a TCP client against its Ethereum address. So now we've got the client connected to the bridge. So what happens next? The user opens the door entry token in his wallet, and the token script engine will ask for a challenge. So it'll send a challenge it'll say, please give me a challenge to token script bridge. The token script bridge just forwards that to the target address, which will be the token script door client. The token script door client generates a challenge, which looks something like this, and then transmits it back to the token script engine. So this just happens via JavaScript promises within the token script, the lock entry.xml that we just edited. So now we are displaying this this challenge. So what happens now? The user, through the Alpha Wallet app, signs this challenge and then transmits the signature back to the TokenScript bridge. So that's now the TokenScript bridge is aware of this signature and also the target that we're speaking to. So it then forwards the signature to the door client via this mapping, and then what happens is the door client will recover the Alpha Wallet address, knowing the challenge and being given the signature. So now that it has the address, the verified address of the wallet, it can then check to see if there's any balance of the door entry tokens at this address, and if there is, it opens the door. And that's going to do it. So if you've enjoyed this video, please send us some feedback, and if not, also send us some feedback too, and let us know what you think. And if you would like to get started with TokenScript, there's plenty of people here at Smart Token Labs who can put you on the right guidelines. There's also a white paper you can read. That's in the github.com/TokenScript repo, and there's plenty of TokenScript examples on the Alpha Wallet repo and the TokenScript repo. Okay, thank you.